Hello everyone. In previous video we have understood oxidation of different alcohols by different oxidizing agents with their oxidizing limits. Out of those oxidizing agent, one was potassium permanganate in acidic medium. Today we are going to discuss that mechanism of oxidation of alcohol by KMnO4 in the presence of dilute sulfuric acid. Topic is not involved in 12th level, but it is important for JEE Advanced and B.Sc. Let's start the mechanism how KMnO4 in acidic medium can oxidize alcohol. Before that, let me recall. Yesterday I told you 1 degree alcohol in the presence of KMnO4 H2SO4, because it's a strong oxidizing agent. First it will convert it to aldehyde and then aldehyde will be further oxidized to carboxylic acid. 2 degree alcohol, if we are using KMnO4 as oxidizing agent, first it will create ketone, and because it's a strong oxidizing agent, it will oxidize ketone further into carboxylic acid and alcohol. And we know alcohol can be further oxidized by KMnO4. So according to alcohol, products will generate, like if it is 1 degree, aldehyde and further oxidation. Carboxylic acid, if contains one carbon, so will convert to CO2 and H2O if contains one carbon. If more than one carbons are there, KMnO4 cannot oxidize this carboxylic acid. 3 degree alcohol, I told you strong acidic conditions are required. Normal sulfuric acid will not work. Dilute sulfuric acid will not work here. Concentrated sulfuric acid is required, which will first do dehydration of it, which will make alkene, and that alkene will be oxidized by KMnO4 into ketone, aldehyde, depending on the condition of alkene. It is not necessary that aldehyde will be generated always, depending on alkene condition. If aldehyde is generated, we know aldehyde can also be oxidized by KMnO4 to carboxylic acid, so further oxidation of it will happen. So this was the summary that yesterday we have covered. Now let's go for the mechanism part. First of all, we need to understand KMnO4. It's a salt which have cation potassium, MnO4. This is the condition of MnO4. This one tetrahedral shape it have. Now Mn is sharing, manganese is sharing 7 electrons with oxygen, and oxygens are highly electronegative as compared to Mn. So 7 electrons are going toward oxygens, due to which this Mn is carrying partial +7 charge. Means this Mn is strongly positive. If it is strongly positive, it can work like electrophiles. Means it can attack on electrons. Who can provide electrons? Alcohols. Let's start. I am using first 1 degree alcohol. This is 1 degree alcohol. This is MnO4 negative. Here you know in MnO4 negative, partial +7 charge it is carrying. Due to this positive charge, the lone pair which is available in oxygen, they will start attacking on Mn. This is the first attack, this is the start of the reaction. As you know, Mn can make maximum 7 bonds. So obviously, out of these 7 bonds, one bond will break. Which bond? Pi bond. Pi bonds are easily breakable. And these pi electrons obviously will shift toward oxygen because oxygen is more electronegative than Mn. Due to which the next condition generated will be this. Now the bond which this oxygen is making with Mn, that will be a dative bond, because when pi bonds will shift toward oxygen, here vacant orbital will generate, which will be filled by a lone pair. So it's a dative bond. And in dative bond, out of these two electrons, one it is shifting completely toward Mn, one it is keeping with itself. That's why it is carrying +1 charge. Mn charge as it is this. This intermediate which is generated is unstable. You can check. Oxygen is carrying positive charge. So first it will break bond from hydrogen and will get electrons back, and H positive ion will be released out because hydrogen has lost its electron. So it is a positive with a vacant orbital. That vacant orbital H positive particle can attack on O negative, because this O negative is carrying 3 lone pairs. Due to which next condition will be this oxygen will get its pair back, so positive charge will finish, Mn OH. Out of 3 lone pairs, oxygen will use 1 pair to make bond with hydrogen, a dative bond, due to which its negative charge will finish. And obviously these oxygens are carrying 2 pairs. Now this intermediate which is generated over here, we call it manganate ester. Now in manganate ester, you can check this part. This part is full of oxygen, and we know oxygens are highly electronegative atoms. So all these oxygens are pulling electrons toward themselves, due to which these electrons which are present between carbon and oxygens are strongly going toward that side. Now if these electrons strongly going toward that side, obviously carbon will attract electrons from hydrogen side strongly, inductive effect, due to which these hydrogens will carry a strong positive charge. That's why these hydrogens are highly acidic. This is the main point. This is the role of MnO4 negative here. Due to MnO4 negative particle, these hydrogens which are available on carbon become strongly acidic, because in Mn lot of oxygens are available and they are pulling electrons toward themselves, due to which this carbon will start attracting electrons from hydrogen side strongly, and due to which hydrogens will carry a strong positive charge. That's why they will become highly acidic. This is the main point. Now let's check what will happen next. Now, as you know, that reaction is happening in dilute H2SO4, and in dilute H2SO4 water molecules are available, because dilute H2SO4 means lot of water, less acid. That water particles always break in two parts, H positive and OH negative. This OH negative part will work as a base and will start attacking on these hydrogens which are highly acidic, due to which bond breakage will happen, and obviously these electrons will shift toward carbon, because carbon is more electronegative than hydrogen, and it will release out as H positive, which will be balanced by OH negative, will leads to H2O. Now, because this carbon will get extra pair, a negative charge, to stabilize itself, it will transfer this pair toward oxygen like this, because oxygen is more electronegative and this whole group is more electronegative, highly electronegative. It is attracting electrons. So the pair of electron which carbon have will be shifted toward oxygen, and we know oxygen can make maximum 2 bonds. So it is breaking bond with Mn, and these electrons will shift back toward Mn. because oxygen is getting electrons from carbon side. So obviously these electrons will shift to Mn, due to which first oxidized product will generate. Check carefully. Which functional group it is? Aldehyde. So 1-degree alcohol will convert itself to aldehyde with this mechanism. And what about this? It will release out as, Mn will release out as Mn. This oxygen was carrying negative charge. Negative charge. Okay. And that O negative, okay, this electron is transferred. Now please check, what is the oxidation state of Mn here? 1, 2, 3, 4, 5, 6. 6 electrons it is sharing with oxygens, and we know these 6 electrons are going toward oxygen, due to which it will carry partial +6 charge, but wait, 1 electron extra it has got from oxygen side. So this +6 will turns to +5. Means after this process, if you check KMnO4 starting condition, so what was the oxidation state? +7. And after this process, what is oxidation state? +5. Means +7 to +5. Oxidation state of Mn is changing during this process. Now next, we know aldehyde will further oxidize. The reaction will not stop up to the aldehydic stage. It will further oxidize. But how? Let's check. We know in dilute sulfuric acid, water molecules are available. Here we have a role of H2O. H2O always break into part, H positive and OH negative. Now here carbon is positively charged, oxygen is negatively charged, because oxygen is more electronegative than carbon, due to which OH negative will start attacking on carbon, and obviously pi electrons will shift toward oxygen because oxygen is more electronegative, which will be balanced by H positive. So here we have a generation of this compound. We call it hydrated aldehyde. And we know it is highly unstable because carbon is carrying 2 OH group, highly unstable. But it is getting generated because lot of water molecules are available. And let me tell you, this aldehyde and this hydrated aldehyde will be in equilibrium like this. All aldehyde particles are not converting itself to hydrated molecule. Few are converting, and equilibrium will be set up there. Now this hydrated aldehyde will react with next molecule of KMnO4. How? Let's check. Again, MnO4 negative particle. +7. Strong positive charge will attract electrons. Who can provide electrons? Lone pair. 2 oxygens are there. Any oxygen you can use. Same mechanism like 1-degree alcohol was doing. Same mechanism. Again, this oxygen will become unstable with a +1 charge and will make a dative bond with Mn. Here negative charge, here double bond. For stability, it will break bond from H, due to which H positive ion will release out with a vacant orbital, which will combine with O negative. And again, there is a generation of manganate ester. OH here and here, double bond. Same, again manganate ester is generated. Manganate ester. Now what will happen? Due to this magnate ester, this hydrogen again will become acidic because lot of oxygens are available. They are pulling electrons toward themselves, due to which these electrons are strongly going toward Mn side, and this carbon will strongly attract electrons from its hydrogen side, due to which hydrogen again will become highly acidic, means partial positively charged. Lot of positive charge will generate on it. Now what will happen? Same, we are dealing with dilute conditions. So in dilute conditions, water molecules are available which are breaking in H positive and OH negative. This OH negative will attack on this strong positively charged hydrogen. Like this. Again, bond will break between carbon and hydrogen, and obviously electrons will shift toward carbon. Because carbon is getting extra electron, it will shift these electrons toward oxygen, because this group is highly electronegative, attracting electrons toward themselves, due to which, check what is generated here. Double bond with oxygen, that's it. This is what? This is carboxylic acid. And this H positive OH negative will combine to produce H2O. And here, because carbon is providing electrons to oxygen, this bond will break, and these electrons will shift toward Mn. Same mechanism like it was happening for 1-degree alcohol. Now what is the oxidation state of Mn here? 1, 2, 3, 4, 5, 6. 6 electrons it is sharing with oxygen. All are going toward oxygen, due to which it should be a partial plus 6. But wait, it got extra electron from oxygen side, so it will have partial plus 5 oxidation state now. In this fashion, this is the mechanism where 1-degree alcohol is converting itself to carboxylic acid. Now, can you tell why carboxylic acid is not further getting oxidized? The reason is it don't have such type of hydrogen. You will say, can't it hydrate itself like aldehyde? No. If you will hydrate it like H positive here, OH negative here, so 3 OH on a same carbon will generate out. It is not possible. Highly unstable condition it is. Once aldehyde can prefer it, but carboxylic acid can't. So that's why carboxylic acid cannot be further oxidized by KMnO4. But if carboxylic acid contains one carbon, this was the mechanism, please check. This is the end of the mechanism. I am dealing with one carbon containing carboxylic acid. It can oxidize. You can check. Same mechanism you can draw for it. Lone pair plus 7, check. Plus 1. Unstable, release of H positive will combine with O negative. Magnate ester will generate OH, O, this one. Now, strongly acidic, strongly electron pulling group. So, this hydrogen will become strongly acidic, positively charged. Now, we know what will happen. Base will attack on it, bond will break. OH negative will attack on it, bond will break, and that bond will shift toward oxygen, and from here bond will break, due to which CO2 will generate carbon dioxide. That's why carboxylic acid containing one carbon means methanoic acid can be easily oxidized to carbon dioxide. But other carboxylic acids, if we have CH3 here, so now you can check hydrogen is not available here. And this hydrogen is required for oxidation. That is not available here. That's why carboxylic acid with more than one carbon cannot be oxidized further by KMnO4. That's it. This is the end of the video. In next video, we will understand 2-degree alcohol oxidation and its mechanism by KMnO4. Thank you very much.